Hi and welcome to another Dech Academy lesson. Here we have question 18 of the June 2013 maths exam, Waec maths exam. And the question says a cube and a cuboid, these are two types of 3D objects, have the same base area. The volume of the cube is 64 centimeters cubed. Notice the unit of cubed for volume, while that of the cuboid is 80 centimeter cubed. Find the height of the cuboid. So the first thing to do is make sure you understand what a cube is and what a cuboid is. A cube is essentially a shape, a six-sided shape where each side, or the face of each side, is a square. So cubes look something like this. I'll imagine you all know what a cube is. However, for a cuboid, it's essentially a stretched cube. So say this side is a square, you have a rectangle shape as the sides, and then you have a square at the other ends. Or, so let's just make this clear that this is a cube. So all the faces are squares. It is six-sided, and because all the faces are squares, all the areas are equal. So this is a square, this is a square, this is a square. The faces inside, which you can't see, are squares. The face here, which is hard to see, is also a square. So I'm gonna assume you know what a cube is, because it's something you just encounter from a very young age. Cuboid is kind of the opposite, because you can have a cuboid looking like this, or a cuboid looking like this. At the end of the day, it looks like a stretched out cube. Forgive the bendy lines, but you need to realize that for a cube, you have square faces and rectangular faces. So let me do the shading differently. The rectangular faces, I need to make this drawing bigger. So this would be a cuboid. I'm just going to break down the cuboid into bits so you can fully understand all the sides. This is one side of a cuboid. The drawing is going to be hard to, well, hopefully not. This should be a square. Let me make this square sort of thing. And this is another side of the cuboid. And then there's a square side there. So in other words, I'm going to shade the rectangular part of a cuboid with red. So this side here is a cuboid. The one to the left, this whole side here. This side here is also a rectangular shape. The base here, it's hard to imagine, but this base here is also a rectangle. And this top here is also a rectangle. So a cuboid has 4 rectangular sides. And then this side here is a square, and this side here is a square. It has 2 square sides. So cuboid, like a cube, has 6 sides. 4 are rectangles, 2 are squares. Whereas for a cube, which will look something like, well, which is this, right? This is 1 square side, this is 2, this is 3. The one here is 4, the one as the base is 5, and the one on this side is 6. So I hope that makes sense. I hope that all made sense, even though it was starting to look a bit messy. So if you have a cube, or less, for a cube or cuboid, the volume is the base area times the height. Base area times the height. For a cube and a cuboid. So keep that in mind. And for a cube, I'll just try and draw a neat one here. So all the sides are supposed to be of equal area. The base is also a square. And all the sides have all the edges of equal length. So if I call this length, this edge here, if I say let this edge have length x, that means all the other edges have lengths of x. So it will get messy if I label all of them, but you get the point. And if I consider just the base area of the cube, all its sides of length x. Wow. If I draw it this way, all the sides of length x. And what's the area of a square? You just multiply the length of, what's the area of a square or rectangle? It's length times breadth. So the base area for a square, I'm going to call it BA. So for square, or let's say cube rather, sorry. The base area of a cube is a square, and the area of a square is the length times the breadth, x times x, which is x squared. As for the height of the cube, remember all the edges have the same length, therefore the height is also x. I'm going to call the height h. Therefore the volume for the cube is base area times height, which is x squared times x, which is x cubed. In the question, we've been told that the volume of the cube is 64 centimeter cubed. Therefore, x cubed is 64. So what is x? X is the cube root of 64, which is 4. So x is 4 centimeters. So I now know the length of all the sides of the cube, which is brilliant. Now they're telling me the cuboid has a volume of 80 centimeter cubed, and I've also been told that the cube and cuboid have the same base area. So remember I told you that a cuboid could look like this, where its base area will be a square. Basically the base area will be this square here, or it could look like this, right, where the base area would be a rectangle. So it would be this rectangle right here, this rectangle here. But since they've told us that the cube and the cuboid share the same base area, i.e. they have the same base area, I'm gonna have to use this configuration. So we're gonna use that configuration. Now I've been told that a cuboid that looks like this has a volume of 80 centimeter cubed. Okay, now since they have the same base area, and from what I determined earlier, the length of the edge of each of the square bases of the cube is x. Since they share the same base, the length of each side here is also x. I don't know the height of the cuboid. I'm going to call it y, another unknown. I'll expect it to be different from the length of one side of the cube, the square base, because we have a rectangle as the other side. Like I mentioned earlier, the volume is base area times height for a cube or a cuboid. So base area times height. I'm going to call height h. Here our base is the same square as before, and the base area is x squared, length times breadth. This time our height, we don't know, we just called it y. However, we know what x is. In fact, we know what x squared is. In fact, we know the base area is x squared, and we know x is 4. So the base area is 16. 4 times 4. The height y we don't know, but we know what the volume is. So we know that the volume is 80 centimeter cubed, and we know the volume 80 centimeter cubed is equal to the base area 16 centimeter squared times the height, which I've called y. I should have left it at h, but let's just call it y. Therefore, I can find y because I have everything in this equation except for one variable. Divide everything by 16 to get y. Or I mean, to make it more obvious, 80 is 16y. So 16y is 80. I want to know what y is. I'm making y the subject of this equation. I divide through by 16. Divide through by 16. to give y is equal to 80 over 16. And that will be 5. So 5 centimeters. Because recall 80 is 80 centimeter cubed. And 16 is an area, centimeter squared. So this is cubed, by the way. So we have 5 centimeters of the length, y, the height of the cuboid. So having done this, I mean, it's fair for me to explain the logical steps that were taken, and that would be taken if you face such a situation in the exam. It told you have a cube and a cuboid. You know what a cube is. A cube is basically a bunch of squares put together to give a shape a shape that looks like this. It's just a 6-sided figure where each of the sides are squares and all the edges have the same length because they're squares. Cuboid, on the other hand, is like an extended cube. It's like a stretch cube. It could take this form or this form. In this form, the base is a square. In this form, the base is a rectangle. The question tells us that the cube and the cuboid have the same base area. Since I know all parts of a cube are squares, and therefore the base area of a cube is always a square, for a rectangle, for the cuboid, sorry, I know I must now take this configuration where the base is a square because of the information given. So I know to use this. Now, I've been told the volumes of the cube and cuboid, and I wrote the equation down for the volume as the base area times the height. The base, I know that I didn't know what any length or edge, the length of any edge of the square or any side of the cube was. So I just said, okay, let the edges be x, because I know the edges have the same length. Therefore, the base area, which I showed here, has all sides equal to x, and the area of a square is the length times breadth. So this is a square, by the way. Area of a square is length times breadth, so that's x times x, which is x squared. So and I'm been told, and the height is also x because it's a cube. All the sides have the same length. So base area times height gives x cubed, which is the volume. But we've also been told that the volume is 64. That means x cubed, which is the volume I determined by using the unknown x, is 64. From that, I go that x is this cube root of 64, which is 4. So I now know what x is, which is brilliant, because if I go to the cuboid, I know it has the same base area. So I didn't even have to work it out. And the base area is the same as that of the cube, which is x squared, which is 4 times 4, because I know x is 4, which is 16. So I knew this. But I don't know the height. I called it y. You don't have to call it y, you can call it h. So the height is y. And the volume for a cuboid is also base area times height. So I introduced the fact that I reused the fact that the volume of the cuboid has been given as 80. I wrote that here, and the base area is 16 times the height. So this equation is basically volume equals base area times height, but for the cuboid. And it gives 80 equals 16y, which is the same thing as 16y equals 80. I make y the subject of the formula to find y. Y is therefore 80 divided by 16, because I divided through by 16. I divided the left-hand side and the right-hand side of the equation here by 16. Now I have y is equal to 5 centimeters. Y is the length, so it's going to be centimeters. The unit is going to be centimeters. For an area, it will be centimeter squared. For a cube, for a volume, it will be centimeter cube. But that's not the main focus. The main focus of this question is getting a number right, which is 5. So I hope that makes sense. Thank you.